Well, hello, retro computing enthusiasts. Mike here. Welcome back to my channel. And today we are featuring the Moro Micro Decision computer again. This computer was featured in a recent Retro Find of the Week video when I got a tremendous deal on it on eBay and got it home. And hey, it just works. And it comes with a whole lot of great software, which I've been having a lot of fun with reliving my youth playing with CPM again. But today we're going to tackle a common problem if you're in the retro computing community. A very common problem. Okay, you've got your snazzy new retro computer over here, and it came with some software, but maybe not some software that you want or need. Okay, I want to play Zork. Zork's not on his. Zork didn't come with the discs that came with the computer. How the heck? How the heck am I going to play Zork? So we're going to tackle the issue of how to get new software into a computer like this. Okay, because it's not connected to the internet. Suppose I want to play Zork. Okay, you've got two problems you got to solve. First, you got to find Zork in a format this thing can run. And secondly, you got to figure out a way to get it into the computer, okay? And today I'm going to show you one way. There's other ways. This way, I think, is pretty simple. It takes a little bit of programming knowledge, though. But I think this is probably one of the simpler ways, and it doesn't require having a second retro computer or modified modernish computer with floppy drives on it to make it work. So let me show you how we're going to do this. Since this problem has plagued retro computing enthusiasts for a long time, and not just, retro computing enthusiasts, back in the day it was a problem too, when this computer was new, and even older computers had the same problem. So there is some software around that will help you get new software onto your machine. But it's kind of the chicken and egg problem because first you've got to get software on your machine to download the new stuff. Okay, but there's ways around that. The CPM operating system has a few applications in it that will help us get new software into the machine over a serial connection. It's a little bit roundabout, and it's going to take a little bit of hands-on programming to make it work. But I'll show you what I did to make it possible for me to download any kind of new software I want into my old CPM box over here. So let's get started. All right, so as I said earlier, we've got two problems here. We've got the problem of finding the software we want, and the second problem of getting it into our old CPM box. So let's see if we can find the software we want first of all. Now, there are a lot of CPM software archives out on the web. CPM was a very popular operating system back in the day, and a lot of people have put together archive sites archiving a lot of that old software. And I'm not going to recommend any particular one of them except this one, the humongous CPM Software Archives, because this is basically an archive of archives. So a lot of these are links out to other archives or to material that they have collected from other archives and cataloged here. So there is just so much stuff here. I mean, the Walnut Creek CD-ROM alone, you could spend probably a day looking at the stuff in there. But there are a lot of archives here. I'm just using Zork as an example. But, just about any piece of CPM software that was at all popular back in the day, and I don't mean wildly popular, I mean used by more than 10 or 15 people and loved by somebody, is probably in one of these archives, okay? It might take some hunting to find it. Their search engine doesn't seem to work all that well, but everything is here somewhere, okay? And Zork exists in these archives in several different places, okay? So, you could search through the Walnut Creek, you could search here, you could search there, and you could probably find Zork. We're just going to go to the Retro Computing Archive down here. And this is commercial software for CPM. And I don't know about the problems with copyright on commercial software here of this era, but it's here, okay? So if we go to Commercial CPM Software Archive over here, and we come, there's all kinds of stuff here, useful stuff. And then there's games. Come down here to games. Oh yeah, so there's names you might remember from back in the day. And a huge collection of CPM text adventures. But look at here, here's Zork. Zork 1, 2, and 3 for CPM 80. That's what we need. So we'll just download that. Poof, okay, we just downloaded it to the computer here. So if we go up here and we look, yeah, there it is. Okay. Let's see here. Extract. So we'll extract that. Okay. So there's our Zork files right there. There's Zork 1, Zork 2, and Zork 3. So we've got all three versions of the game right here. Very cool. Basically, to run Zork 1, which is what I'm trying to do here, we need to get this file and this file into the Moro micro decision somehow. So how are we going to do that? Well, now we need a different piece of software. We got to hunt up some other stuff and figure out how to get that in the micro decision. But okay, the next problem is getting our Zork software into our micro decision CPM box or any other CPM system you might be working with. So for that, we need to go to another website right here, dramp.com, Vintage Computing. Welcome. This website focuses on early personal computers from the mid-70s into the early 80s. Here you'll find resources for restoring and maintaining many of the great computers and peripherals from this area and from this era. And there's just a lot of amazing resources here on vintage computers, rare computers, hard to find stuff, okay? Unfortunately, we're not working with any of these crazy, valuable vintage computers here. We're working with a Moro micro decision, which, isn't worth a fraction of what an Altair or a Southwest Technical Product Corporation or even a North Star computer is worth. But still, the software is very similar. So, and speaking of software, all his software is over here in the downloads section, arranged by computer type. Okay. Now there is a Moro section, but unfortunately it deals with the disk jockey card for S100 boxes. And well, we're not working with an S100 box. We don't have a disk jockey card. And the disk jockey card uses completely different hardware than what's in the micro decision. So unfortunately, the stuff in the Moro archive here doesn't do us any good. So I did a lot of looking around in here at all of the different computers in here and the hardware they use to try and find something similar to the micro decision. And actually, there are a couple of computers in here. Mostly they're S100 boxes again, but they did use very similar hardware for their serial interface. And that's where we need to have the similarity, is in the serial interface, because we need to get the data in and out of the micro decision via the serial ports. So if we can find software for doing that, that uses the same sort of UART chips as in the micro decision, hey, we're 99% of the way to having what we need. So there are a couple of these older computers that do that. I have settled on the North Star down here because the North Star, I think, is as close to the micro decision as we can get. It needs the least tweaking to get us where we need to be. We are going to have to tweak it a little, but not as much as a lot of the other computers. So we want to go to Horizon. The North Star Horizon is the machine that seems to be the most similar on the hardware level to the Morrow micro decision. And the programs we need are PCGet and PCPut. So we click on this, and here we go. We have the programs in assembly language, which is convenient because we are going to have to modify the assembly language a little bit. Things are not exactly identical to the micro decision. So the North Star Horizon is close. Very, very close, but it's not exact. So we're going to have to modify the programs. But we need the two programs, PCGet and PCPut. And what PCGet does is it gets files from another computer connected to your CPM box over the serial connection. Then PCPut puts files from your CPM box onto another computer over the serial port. So when you have both of these programs, you can have two-way communication between your CPM box and another computer. Be that another CPM box or a more modern machine like the one I'm using here, a Windows 10 laptop. As long as the machine has a serial port and a terminal or terminal emulation program and X modem installed, you can have two-way communication between it and your CPM box. So this is how software was transferred between machines back in the day. So we need to download PCGet ASM, and we need to download PCPut ASM. And now that we've got them, we need to make some changes to them and then get them into the micro. Okay, so what we have to do next is pretty specific to the micro decision. Now, if you've got a different CPM box and you're trying to do this, you're going to have to dig up some different literature, and you're probably going to have to find a different version of PCGet and PCPut to use. Okay, or if you're a really good programmer who's got really good skills with 8080 assembly language, you could probably modify just about any version of PCGet or PCPut to work with your system, but you got to have some skills. Again, this is specific to the micro decision. Now, if you have like an Altair, an Insight, a North Star, or a lot of those other systems that are on DRAM's website, you can probably download a version of PCGet or PCPut that will work for you right out of the box. Unfortunately, we're not that lucky. And if you've got some other less common or less popular brand of CPM box, you're probably not going to be that lucky either, and you'll have to do some modifications. But your modifications will be different than what I'm about to do. So I have here the micro decision service guide for all the micro decision models. And this is an important piece of literature. When I bought the micro decision, I downloaded every service guide, every user manual for it I could find, because you got to know a bunch of stuff about these computers to maintain them these days. There is no factory service anymore. That's me. I got to fix it when it breaks. If I want to do something new with it, I'm the one who's got to do it. So, we got drive connector pinouts, jumper pinouts, parallel port addresses. Serial port addresses is what we need to know. So, micro decision port addresses. So let's go, that's page 5-2. So let's scroll down to page 5-2 and find that. Yes, here we go. This is the info we need to modify the versions of PCGet and PCPut we just downloaded from dramp.com. There was no standard back in the day about where the address of the serial port UART should be in the I/O space. So different computers put them different places. So the North Star Horizon has the closest hardware and software to the Morrow micro decision, but it put that hardware in a different location in the I/O map. So that's what we're going to have to modify. So if we come down here into our downloads directory and we get PCGet, okay, and we open it, and we're going to keep this simple. You don't have to have any fancy editing software. We're just going to open this with Notepad. You can open it with any editor. You can even edit this in CPM. I don't recommend it though. CPM editors were pretty primitive back in the day and very hard to use. So what have we got here? We've got the assembly language program for PCGet. Okay. So up near the top of the program are the equates. Basically, these are constants set by the programmer that tell the program where certain things are. And right up here at the very top, we got port A control register, we got port A data register, port B control register, and port B data register. So this is the stuff we need to change. And if you look over here, first serial port data and first serial port status. So if you think status and control register are basically the same thing, first is A, second is B. So if we just take the numbers over here and we put them in over here, this program should work then. So let's do that. Let's edit this program. So port A control register. So that would be the same as port A, or the first serial port status register. That would be OFD. So we'll put in, or 0FD. And we need to put an H on the end of it to tell the assembler that we're talking in hexadecimal here. And the leading 0 is important, or you'll get an error later. We'll talk about that later. So let's see, port A data register, that is OFC, OFCH, okay. We're not going to use any more than the port A on this, but we're going to go ahead and modify the port B too, just to be thorough. I mean, the Morrow does have 2 ports. I could see some possibility in the future of using port B. So we'll go ahead and we'll modify the port B numbers too. So port B control register, well, that would be second serial port status. That would be OFF. H. And then down here, port B data register is OFEH. All right. So there we go. Now that should be the only changes we need to make to this program. So if we save this, now it's just a matter of getting it over into the micro decision and assembling it using the assembler that's built into CPM and comes with every CPM distribution. And CPM has a way to do that, and I'll show you how to do that next. All right, but before we do that, let's do one more thing just so we're all set and ready to go. So let's bring up the PCPut program that we also downloaded. And if you look through the code on it up here near the top, you've got the same equates up here. So if we change this section to match this section of PCGet, then PCPut should work as well. And we could just cut and paste. we'll just cut and paste, or copy and paste, I should say. We'll just copy this, and we'll bring it over here, and we'll paste it right in here. Now there needs to be, there we go. And there we go. So let's save that. So now we've got both programs ready to be transferred over to the micro decision or whichever CPM box you're using. So that's what we'll do next. All right, let's unclutter the desktop a little bit so I can get to TerraTerm over here, and we'll start a TerraTerm session. Serial. Port 8 is where I have my USB to RS-232 dongle to talk to the micro decision. I'm going to make the font a little bigger so you folks can follow along a little easier. And we're going to do a little setup here. We are going to go into serial port, and we're going to put a transmit delay in of 10 milliseconds per character. We need that for what we're going to do next. We'll take that out later. At least hopefully we'll remember to take it out later. It will make transmission a lot quicker on other stuff. Okay, time to boot up the micro decision. Let's see, I've got the right disks in. Disk drive doors are closed. Power on. Okay, it's testing its memory, and it will shortly boot into CPM off of the A drive. Okay, so we're booted up. Let's go look at the B drive. Alright, so I have prepared a disk that's in the B drive. I formatted it and I copied 3 programs over to it. pip.com, load.com, and asm.com. These are the 3 programs you need to get PC put and PC get over onto the micro decision or your CPM box, whatever machine you're using, and get them up and running. So you're going to need to do the same thing. So the first thing we need to do is run pip. And I will explain something here. I am typing in lowercase just out of habit. Case doesn't matter in CPM. Everything you type automatically gets converted to uppercase. So I'm just typing in lowercase out of habit. You can type uppercase, you can type lowercase, you can mix it up. It doesn't matter to CPM, it's all the same. So we're going to run pip first. Pip is the program that comes with CPM. It's for copying files and doing a lot of other stuff. The manual pages on pip go on and on. It's a very powerful program. It does all kinds of things. So next we're going to type pcget.asm equals :. Okay, so basically what we're doing is we're running pip and we're telling it to open a file called pcget.asm and copy anything that comes in over the console, which is basically the A or main serial port on the micro decision. Copy anything that comes in over the console into that file. So this is what this command is going to do. So if we hit enter, now pip is running and it's just sitting there waiting to hear something come in over the serial port connection. So what we're going to do is we're going to come here in TerraTerm to the File tab, and we're going to come down to Send File. We don't want to do transfer, not yet. In the future, once we have PCGet working, we'll be doing transferring. But for now, we're just going to send a file. We're going to send it as ASCII, and we're going to find pcget.asm, and we're going to send that. And there it goes. And this is going to take a little while. Our transmit delay slows things down a little bit, but it's necessary because we can send data a lot quicker than CPM can handle taking it in and putting it into the file. So the transfer delay will prevent the file from getting corrupted information. So I'll just fast forward through this until we get to the end of the file. Okay, and then once we have reached the end of the file, we have to tell it that the file is done. And by doing that, I'm going to type a Control-Z on the keyboard here. All right, so we should have PCGet in the micro decision now, the PCGet.asm, the assembly code in the micro decision. Okay, a quick word about what I just did here with this transfer. You might be thinking, why didn't you just assemble PCGet with a CPM emulator or something? And I have a CPM emulator. I have a couple of different computers with emulators where I can actually run CPM on them. I could have assembled this program on those computers, and I would have had an assembled executable file. But the problem is getting that file into the micro decision. You can't do it this way. This transferring over the serial port like this, basically you're expected to send text, and it doesn't handle the non-printable characters correctly. And if you're sending an executable file, it could have any of the 256 characters in there. In any particular byte, and they're just not going to be handled properly, and it doesn't work. So you got to send the file as text over to the micro decision and use the assembler over there. Now, if you have a CPM emulator, there are other ways to do this, and we might do a video on that in the future, but I'm assuming you don't have a CPM emulator here. You only have a CPM box, okay? And so this is why I'm doing it this way. So we should have PCGet.asm on the micro decision now. Let's take a look at what's on the B drive. Yes, there's PCGet.asm. Let's do this. Let's type it and see if we got it correctly and it's not all corrupted. So the type command just, well, does what it says. It types whatever's in the file out to the screen. So there we get to see our program again, although it's scrolling by pretty quickly. It does look like it's okay. I mean, we're not going to see, a small glitch in there somewhere that screwed up 1 or 2 bytes, but we can see it's not totally corrupted. It's all there, so that's good. All right, next we need to assemble it. We've got the assembly code over there. We need to assemble it. For that, we're going to use CPM's built-in assembler. And here it is, asm.com. That comes with every CPM distribution. So we're going to assemble it. We're going to type asm pcget. You don't have to put on the extension because ASM is going to assume if you're running the assembler that the extension on the file you're sending it is ASM. So that's the default. So let's hit return and see what happens. Okay. So anyway, the CPM assembler is not very verbose. But if you get something that looks like this, you had a successful assembly. All right. I'm not going to go into what all these different lines mean. It's in the manual. RTFM. Okay. So let's take another look at what's on the B drive now. So we have PCGet ASM, which we started with, PCGet PRN, which is a PRN file, which is something you get when you assemble it. And then you've got PCGet hex. And this is basically a hexadecimal version of the executable file. We can take a look at that. So this is an Intel. So this is an Intel format, Intel hex format. This is just one way of representing executable code for the microprocessor. And let me go back up here. It should start at 100 hex. And yes, it does. It doesn't start at 0. Good. So it should start at 100 hex. That's the way it's supposed to with CPM. And yes. Now, I was talking earlier about emulators and assembling the program on a PC with an emulator. And if you do that, you can wind up with this hex code. And you can send this hex code the way we sent the assembled file over. And it's a little bit easier to do it that way. There's fewer steps. The hex code is shorter than the ASM file. So you could do it that way. But, you know, I'm just assuming anybody out there who's watching this may not have a CPM emulator on their PC, and they've just got a shiny new 50-year-old CPM box sitting in front of them, and they're trying to get some software into it, okay? So, all right. So we've assembled it. Next, we're going to use the load program. And we're going to put pcget.hex into load. And I'm not sure that the extension is even needed, but we're going to put it in there anyway. And what load is going to do is it loads the hexadecimal file up here, the Intel hex file. It loads it into memory at the starting address where it says it wants to start in memory. And then it writes the file out of memory to a disk as an executable file. So if we do another directory, look at the directory again, we should now have pcget.com as an executable file on the disk. So we had to jump through a few hoops, but in the end we've got there. We've got pcget on the micro decision. So we should be able to use it to transfer other files over to the micro decision now. Pretty much any file we want to, including executables. Let me go back up here to setup, and before I forget, take out our 10 millisecond delay because we don't need that anymore. Okay, and let's try running pcget and see if it's actually going to work. Hopefully it will work after all our effort to get it over here. So what are we going to bring over? Well, we might as well bring pcput over and assemble it. So we'll start with pcput. So we'll do pcget, and then we need to tell it the file we want to bring over. pcput.asm. Now, if you were using an emulator on a PC, you could actually compile pcput and send the executable file over. But we're assuming you're not using an emulator, so we're just going to try it this way and see what happens. Okay, it's wanting me to send the file using Xmodem. So now at this point, we're not going to send file like we did before. We're going to use transfer. We're going to transfer with Xmodem. We're going to send, and we're going to get pcput. And look at that. It's transferring over. And look at the speed. Look at the speed. Because we don't have the time delay in there anymore per character like we had before. So this is going really quick. So that's great. And also, since we're using the Xmodem protocol, there's error checking and correcting involved. So we're going to get a good file every time. And if we do a directory listing, well, what do you know? There's pcput.asm right there. And of course, we can do the same thing that we did with pcget. We can assemble it and then load it. And then we'll have the executable file here on the micro decision that will allow us to transmit files from the micro decision uphill to whatever computer you have connected to it over the serial port. So now we'll have two-way communication. So we'll do that real quick. I'll just go through it real quick. Oops. Boy, it would help if I could spell, though. Yeah, let's try that again. Assembling away. And there we go. Looks like a good assembly. Let's do a load. Okay. And another directory listing. So, okay, so there's pcput.com now. So now we have our executable. And what I'm going to do is I'm just going to clean things up a little bit. I'm going to get rid of the PRN and the hex files because we don't need them anymore. They're just kind of in the way. And also I've got some files on there from my misspelling that need to go away too. So we'll do an erase, ERA, and we'll use the wildcard, and we'll do all the hex files and get rid of them. Oh, again, it would help if I could enter the command right. ERA space dot. Oh. Dot hex. Okay, and then we'll do ERA wildcard dot PRN. And then if we look at the directory again, so that's a little bit cleaner now. We just basically have the files on there that we want. We could actually even get rid of the ASM files. We don't really need those anymore either. Free up some space on this disk. All right, yes. So now we have PC get and PC put in the micro decision. We can transfer over Zork or whatever else we want to transfer over to the micro decision. So let me do that, and it'll be mission accomplished. Okay, so let's go ahead and get Zork on the micro decision. Now I have just determined that we have 164K of space left on the B drive. Could free up a lot more room on the B drive by getting rid of pip, load, and ASM, but for now, not going to bother. Use the stat command for that. Now let's take a look at Zork. Zork1.com is 9K bytes, and Zork1 data file is 83K bytes. So these are the two files we need to get onto the micro decision to run Zork. So okay, it looks like we have space. So let's do it. Let's do PC get. And then what are the names of the files? I just minimized them too quickly. Zork1.com and Zork1.dat. So that's what we need. Zork1.com. So we will send it or transfer it using X modem. Send, let's see, Zork1.com. And there we go. Okay, transfer complete. So let's do that again. Get the data file. This is going to take a little while because this is a pretty big file. We'll be back when it's done. Okay, transfer complete. That took a couple of minutes because that was a pretty big file. But if we do a directory listing, so we've got Zork1.com and Zork1.dat on the B drive. So in theory, I should be able to play Zork now, which is where all this started. Let's try it. You can hear the disk drive grinding away in the background as it's loading the program. Aha! Yes, here we are. The Great Underground Empire. Oh, I remember this from back in the day. Reveals a leaflet. Zork is a game of adventure, danger, and low cunning. In it, you will explore some of the most amazing territory ever seen by mortals. No computer should be without one. Well, guess what? My moral micro decision is now not without Zork. It has it. And I could bore you to death by playing a long session of Zork here, but I don't think I will. But I will say that Zork is just the beginning. The whole universe of classic CPM software is now available to my micro decision. I can get anything I want into it. And if I need to get data or files out of the micro decision and into another computer, well, I've got PC put to do that. So we are communicating, and that's great. So, I have plans for the micro decision. I want to do lots of stuff. I need to get other stuff in here. As soon as I'm done, playing some Zork, I want to get some classic basic files over here, so I don't have to type them all in at the keyboard. I can just transfer them over and run them under the versions of BASIC that came with the micro decision. I would like to get micro C on the machine so I can program in micro C. I may play around with Forth. I played around with Forth a lot back in the day, and it still kind of fascinates me, so I may get Forth on the micro decision and play around with it some. Among other things, the sky's the limit. The sky is the absolute limit here. There's all that software that I showed you over at the humongous archive and more is available to us now. I could spend the rest of my life loading that stuff into the micro decision and playing around with it. Well, there you go. All right, I would call that mission accomplished. I've got Zork into my micro decision. I've got it set up so I can transfer anything else I want to into it or out of it. So this computer just became a whole lot more useful and a whole lot more fun. Plus, I learned a couple things along the way, and I hope you folks learned a couple things too. Useful stuff. So if you found this video at all educational, interesting, informative, inspirational, whatever, give it a like, give it a thumbs up, and subscribe to see my future videos. There will be more videos coming out on all kinds of electronics and retro computing subjects here on this channel. And check out my two other channels, Omega Geek 64 and Mike's Lapidarian Fossils. There's good stuff going on over there all the time too. And I'll see you in the next video. Thanks a lot for watching this one. I'm going to go play some more Zork. Bye.